Hey guys, this is Coach Lowe, and this is Geometry, Chapter 1, Section 5, Angle Relationships. So we're going to talk about some different terms that we use in geometry to help identify the different relationships between angles. So first of all, let's talk about adjacent angles. Adjacent angles means, so when you think about something being adjacent, means next to. So when we talk about adjacent angles, that's what that means as well. They will share a side and a vertex. So here's my vertex. And here is a side that's shared by two angles. So see if you can locate those two angles that are sharing that side and the vertex. So here's angle 1. And then here is angle 2. And notice when I trace angle 2, I go back over that blue part. And so those two angles are considered to be adjacent angles. Angles 1 and 2 are adjacent angles. Why? Because they share a vertex and a side. So make sure that you can answer that why question when you come back to class. All right, let's talk about linear pairs. Linear pairs. The name should make you think there are going to be two angles here, and this should also make you think they're going to make a line. So thinking about that, you have two angles that form a line. Let's go ahead and draw a picture of that. Let's go ahead and draw a line. And then I want you to draw a ray off of that, and I don't really care where you draw it. It doesn't really matter. So let me go ahead and put arrowheads on the end of that. These two angles are called a linear pair. Can you pick out the two angles? Go ahead and mark those. So here is angle 1, and here is angle 2. Angles 1 and 2 form a linear pair. So here's linear pair. They share a side, they're adjacent angles. All right, so I have two angles that are adjacent. They're going to have a common side, and then the side that's not common is going to form a line. So these two rays that are in the non-common side form a straight line. So you can see that this is my line right here that is formed by the two non-adjacent sides. So that's a linear pair. Linear pairs measure how much together? What do you want to guess on that? How much would that be? Yeah, exactly. 180 degrees. It's a semicircle, right? I could complete it all the way around, but you can see that I have a semicircle. Okay, so linear pairs, be able to answer that one when you come back. So linear pairs add to be 180 degrees. Let's talk about vertical angles. There's a C in there. Two angles are vertical angles. So when you have two intersecting lines, we will always have two angles that are vertical angles. We don't know their measure exactly, but here's what we do know about them. These two angles are congruent. So vertical angles are congruent in measure. So angles 1 and 3 would be congruent, and then angles 2 and 4 would be congruent to each other. All right, so they're congruent in measure. Now, you could also pick out here 1 and 4 are a linear pair, 1 and 2, 2 and 3, 3 and 4. Those are linear pairs that we just talked about. So I have vertical angles in this picture, but I can also talk about linear pairs. So I know that vertical angles are equal in measure. So if I know the measure of angle 1, I also know the measure of angle 3. Then I can use linear pairs and find 2, and then I would also know 4. All right, complementary angles. Complementary angles add to be 90 degrees. So I have two angles that add to be 90 degrees. They do not have to share a common side, so they do not have to be connected together. So I could have an angle here and an angle over here. And this angle could be 27 degrees. And this angle could be 33 degrees. Sorry, not 33 degrees. Let's back that out of there. this angle could be 63 degrees. So I know that these two angles, so if the question is, are these two angles complementary angles? The answer is yes, because 27 plus 63 is 90 degrees. So they are complementary angles. Now, if those two numbers do not add to be 90 degrees, then they're not complementary. Notice my angles are not connected to each other. They could be, that's an option. That's fine if they are, but they do not have to be. So complementary angles, two angles that add to be 90 degrees. All right, supplementary angles. Supplementary angles add to be 180 degrees. Two angles again. All right, so again, two angles that add to be that's an angle. Two angles that add to be 180 degrees. They, again, do not have to be connected to each other. So I could have an angle here. And let's say that this one is 40 degrees. And then I could have an obtuse angle over here. And that, let's say that one's 140 degrees. Are these two angles supplementary? Absolutely they are, because 140 plus 40 is 180 degrees. So those angles are supplementary. All right, here's my question for you. If I draw a linear pair on the board, are those two angles supplementary? So here's my question. If I draw a linear pair, this is A, B, C, and then C, B, D, are they linear pairs? And the answer is yes, they are. That's exactly right. They are linear pairs because their back side that's not common, the ray that is not common, the back of those angles forms a line. And then they share this common side and a vertex. So they are linear pairs. So linear pairs are supplementary. Remember we talked about those adding to be 180 degrees. All right, last thing. Perpendicular lines. Two lines that intersect, and at their intersection forms right angles. Now we already talked about when two lines intersect, we have four angles that are formed, but if lines are perpendicular, and there's a symbol for perpendicular, so if lines are perpendicular, then they form four right angles. All right, so four right angles are formed. I also know this. If one angle is 90 degrees, then don't I know that they're all 90? Vertical angles are congruent, and then I have a linear pair here, so 180 minus 90 is 90. So if one angle is 90, I know all four are 90. So two lines that cross, if they're perpendicular, then we know that their angle measures are 90 degrees. All right, two examples that I want you to try. So draw two lines, and I'll give you a hint on these, and then we'll talk about them when you get back to class. So 4x plus 3 here, and 107 degrees here. So this is a degree measure. All right, so think about what you know about these two angles. What types of angles are they? Are they vertical or are they a linear pair? Are they across from each other? Are they side by side? Because remember, linear pairs have to be adjacent. They have to be side by side. That's right, they are vertical angles. And what do we know about vertical angles? Vertical angles are exactly congruent. So that means those two are equal in measure. If those two are equal in measure, then I know that I can set them equal to each other, and I can solve that equation. So go ahead and solve that equation, and when you get x here, that's your solution. But for your check, I want you to plug it back right here, because this, when I do 4 times whatever you get here for your answer plus 3, it should be 107. Those should be the same measure. So find out what x has to be to make this 107. All right, and we'll talk about it when you get back to class. All right, here's your second example. You can pause the video and finish that one if you want to and then come back, but here's your second example. This is 3x plus 6, this angle, and this angle is 2x plus 4. All right, so What do I know about these two angles? They are side by side, they're adjacent angles, which makes them a linear pair. So these two angles added together must equal, right, 180 degrees. So think about what I just said. These two angles added together must equal 180 degrees. So this was an angle measure and this is an angle measure. All right, so we will solve this equation, put like terms together, find out what x is, and then I want to know the measure of angles 1 and 2. So this is angle 1 and this is angle 2. So I want you to find those measures for me, and then we'll talk when you come back to class. Make sure that you understand what you're doing, and then I have some fun stuff for you to do when you get back. Fun as in, you know, my definition for fun now. Challenging, make you think a little bit, you know, fun. All right, guys, I'll see you soon. This is Coach Lowe, and I'm out.